So, there's this project I did in the past that I've been meaning to redo. It was a color picker that I made in JavaScript. You've probably seen one if you've used the professional editing software like Photoshop. The project was meant to show off my CSS and JavaScript skills to employers, but instead, it showed me that I still had a lot to learn. So I decided to revisit it to not only do it right this time, but also to see how much I've improved. For the language, I decided to use TypeScript instead of JavaScript. I know some of you are probably wondering why I didn't choose the latter, even though I'm making a color picker for it. And that's because TypeScript is still JavaScript but with static typing. To those of you who aren't programmers, here is ChatGPT's explanation of what static typing is. Feel free to pause the video if you care. I'm also using the jQuery library to make working with HTML in TypeScript easier, and also because I didn't want to worry about cross-browser compatibility. Since I wanted my color picker to be a package, I decided to integrate Webpack. I did this to simulate bundling, which is what developers usually do with third-party JavaScript code. Bundling is just a way to merge multiple JavaScript files into one. This reduces the number of JS files a browser has to get from a website server. In other words, it makes a website load faster. Lastly, for my own convenience, I'll be writing all the CSS with Sass. The advantages of using Sass are kinda difficult to explain, so I'm gonna let ChatGPT do it. Okay, so here's what my setup looks like with all the prerequisites. One of the things I regretted not doing in my previous attempt at making a color picker was not learning color theory beforehand. So this time, that was the very first thing I did. I went on the internet and searched up color theory, and I learned about the different color models, color schemes, the difference between hue, shades, tints, and tones, fancy terminology like saturation, additive and subtractive, and even the history behind it all. After gathering all of that information, I decided it was finally time to start the color picker. I chose to do the graphical user interface first. The reason for this is because in my previous attempt, I learned that adding new features to the color picker later introduces problems that can affect the entire program. So I decided it was best to include all the GUI components required at the start. To determine what components were needed by the color picker, it was important to know what a color was made of. This is where color theory comes in handy. A color has a hue, which is usually what people think of when they hear the word. This can be red, blue, green, orange, and so on. A color can also have a shade, a tint, or a tone. Collectively, this is known as its chroma. Hence, a color picker needs at least two components, one for the hue and one for the chroma. I could make separate components for the shade, tint, and tone, but existing color pickers already show that they can be combined into one. There is also a third component, which determines the opacity of a color. It's known as the alpha channel. Lastly, I'm going to add another component that displays the selected color and allows the user to search for a color. I'll call it the search bar. Now that I knew what components the color picker will have, it was time to design the layout. I decided that the shape of every component would be rectangular in order to keep things simple. Originally, I wanted to do something fancy like this, but I had a feeling it would not be worth the trouble. I started by making a wireframe of the layout. I created a rectangle for each component and gave them all a different color. Then I arranged them like this. After that, I created the gradient for the hue. For some reason, instead of looking up the colors that make up a color wheel, I used arbitrary colors to make the rainbow pattern. I corrected this later on. Next, I worked on the alpha channel. The convention is to have a checkerboard pattern as the background so that the change in the selected color's transparency is easier to see. This pattern took me a while to replicate with CSS, but eventually I figured it out. Basically, I had to create a pattern that looked like this, and then duplicate it to fill the entire background. To get this pattern, I needed 4 different linear gradients. Each gradient consisted of 2 colors, a transparent one and a solid one. The solid color only filled up a quarter of the gradient, meaning most of it was transparent. Since I didn't want the transition to fade, I made the transparent portion start where the solid color ended. The gradient had to be rotated diagonally and clipped into a small square. The result looks like a triangle. This procedure is repeated for the other 3 linear gradients, with a slight few adjustments to the rotation and the color transition. It gives a total of 4 triangles. To make the pattern, the triangles that point in opposite directions are joined together. This pattern is considered the background image in CSS, so to get the checkerboard pattern, all I had to do was repeat the image. I know this seemed like a roundabout way of making tiles, but it was the only way to create the checkerboard pattern purely in CSS. Any other way would have involved working with HTML or images, neither of which are scalable or efficient. I realized as I was making the checkerboard background that I needed another HTML element on top for the selected color's alpha gradient. So I added one and gave it a linear gradient background. This combined with the checkerboard background gives the effect that the selected color is gradually becoming transparent. For the search bar, since I wanted the color picker's initial color to be red, I set its background to that, and I also set its default input to the RGB color code of red. The final component is the chroma. At the time I didn't know this term, so I just called it the shade and tint component because of how the gradient is made. You see, it's comprised of 2 linear gradients. One goes from black to transparent and the other goes from red to white. The first one is like the shading since it's adding black to the hue, and the other one is like the tint since it's adding white, hence the name of the component. The shade gradient goes from bottom to top and the tint gradient goes from right to left. Even though the tint gradient is below the shade gradient, it's still visible because of the transparency in the shade gradient. After I finished the CSS for the components, I decided to change the background color of the color picker to something darker so that the components stand out more. I also added sliders at the top of the hue component in the alpha channel to aid the user with their selection. I was planning on adding a draggable element to the chroma component as well, but I postponed it for later. Now that the GUI has all the key components, I decided to create a class for the color picker. For those of you who aren't programmers, a class basically allows me to write a blueprint for the color picker. Other people will be able to use this to create as many color pickers as they want, and I would only have to write the code for it once. I wanted my class to generate the HTML for the color picker, but it needed to know where to do that on the web page, so I added a requirement. Basically, in order to create a color picker, a developer needs to pass in the ID of an element. This element acts as a container for the color picker's HTML code. Now that I had a way to place the color picker on the web page, it was time to add in the code that allows it to generate its own HTML in the container. This was pretty easy, because all I had to do was copy and paste the HTML code I already had for the color picker in the class. I deleted the original one afterwards. The next thing I did was get the references to the HTML elements of the color picker's key components. This allows me to manipulate the components within the class. Note that these references only refer to the components of the color picker that is using them. To put it simply, each color picker created with the class has its own references that point to its own components. I then added a class property to hold the RGB values of the color picker's initial color. I used this to reinitialize the default input for the search bar. I was planning on implementing a way to resize the color picker, so I changed its box sizing CSS property to border box. This means that it will now have the exact width and height the developer specifies. Without this, the padding of the color picker's components will add on to its size, which would make it much larger than it should be. If I wanted to let a developer resize the color picker in a certain way, I needed to implement what's known as an Application Programming Interface, or an API for short. Basically, I'm going to write code within the class that other programmers can use outside of the class in order to exchange data with a color picker. In this case, I expect them to give the color picker a new width and height.
You're not that guy, pal, trust me.
This can be achieved in classes by creating methods. I made one called setSize, which takes 2 numeric values for the width and height and uses them to dynamically create inline CSS for the color picker. This overrides its default dimensions, which resizes it. When I tested this, I realized that the search bar's font size didn't scale with the color picker. Unfortunately, CSS didn't have a one-line code to fix this, so I had to come up with a workaround, which involved using a little over half of the search bar's height as the font size. This meant that the text will never be larger or smaller than that percentage of the search bar's height. Also, since this code is inside of the method, the text will change size whenever the developer resizes the color picker. The setSize method allows the developer to change the absolute dimensions of the color picker, but what if they only wanted to enlarge or shrink it without affecting the aspect ratio? My solution to this problem was to create another method that only asks for a number that will be multiplied with the color picker's current width and height. Passing a value less than 1 to the method shrinks the color picker, a value greater than 1 enlarges it, and a value of exactly 1 has no effect. Later, I realized that I could use the set size method to implement the same logic, so I updated it. This was a lot better because it meant that changes to the resizing mechanics will propagate to this method. In other words, I only had to worry about the set size method. Some applications keep color pickers hidden until a button is clicked. The same button may also be used to hide them again when they're no longer needed. To give developers the option to implement this behavior in their programs, I created 2 methods that change the visibility of the color picker. They're self-explanatory, so I won't say any more, but I will show you how they can be implemented. I left the API methods for now and decided to start the mechanics of the color picker's components. I started with the hue component since that seemed like the easiest. I wanted the user to be able to change the hue by clicking anywhere on the gradient or by dragging the slider up and down. For both cases, I needed to create what's known as an event. To put it simply, events allow my program to detect and respond to the action of a user. In this case, I wanted the color picker to detect clicks on the hue component and also detect the movement of its slider. For now, I'm only going to be focusing on clicks. In JavaScript, events are attached to HTML elements. I decided to attach a click event onto the element of the color picker's body rather than the hue components, because then I'd be able to share with the other components later. This is called event delegation, and it is a lot more efficient than making a click event for each component. Since I wanted the color picker to respond to clicks in the hue component, I created a condition that will check if the click originated inside it. After this, I got a little bit sidetracked. Instead of creating the code that will grab the position of the mouse click on the hue component, I decided to make its canvas. In JavaScript, a canvas is an element that allows you to create graphics like images dynamically with code. It also provides its own API for reading graphic data, which is what I needed in order to know what color the user selects. This is going to sound complicated to someone who's not familiar with JavaScript, but I'll try my best to explain my intentions with the canvas. So just to be clear, the canvas and the hue component are 2 separate entities made with 2 different HTML elements. However, both of them will have the hue gradient as the background. The hue component is visible in the color picker's GUI, but the canvas isn't. And unlike the hue component, the canvas cannot be interacted with since it's hidden, hence it won't be clickable nor have a slider of its own. It only has the gradient. The purpose of the hue component is to get the coordinates of the mouse and use those with the canvas's API in order to read the hue that was selected by the user. I know some of you are probably wondering why I didn't just use the canvas in the first place, and that's because in my previous attempt at making a color picker, I ran into a lot of bugs with getting the canvas to work with events and draggable elements. Maybe it was just my lack of experience at the time, but I told myself that if I ever redo the color picker, I will keep them separate. In order for my idea to work, the hue component's canvas needed to stay the same size as the background of its counterpart. So to make sure of this, I added some code to the resizing method that would ensure their dimensions matched. After doing that, I decided to go back to the click event again to implement the response. Just to reiterate, when the hue component is clicked, the selected color is supposed to change and the slider is supposed to move to the spot where the click occurred. To achieve these effects, I needed to get the coordinates of the user's click and pass it to the API of the hue component's canvas. To understand how this works, I must first explain the coordinate system in JavaScript. As you know, websites are 2-dimensional in nature, which meant that I only had to work with the X and Y axes. You're probably used to seeing the coordinate plane oriented like this, but in websites, the origin starts at the top left corner. This means that the Y coordinate now increases as you go down and decreases as you go up. So if I wanted to get the position of the mouse in the hue component, I needed to get its coordinates relative to the top left corner of the component. There was a small problem. Since the event was attached to the element of the color picker's body and not on the hue component's element, the coordinates given by the click event was relative to the top left corner of the color picker and not the top left corner of the hue component. This can be corrected by subtracting the click's coordinates from the offset coordinates of the hue component's top left corner, which is what I did here. Now that I'm able to read the coordinates of the click, I decided to write the code that moves the slider to that spot. Since the slider can only move up and down, I only had to use the Y coordinate of the mouse. To center the slider on the tip of the mouse, I subtracted half of its height from the Y coordinate so that its top edge is not below the tip. I also added conditions to keep the slider inside of the hue component. This is for when a click occurs on the top and bottom edges. Since all of this code is executed by a helper function, it meant that I could reuse it for the alpha channel. So I did just that, and now the sliders of both the hue component and the alpha channel respond to clicks. Here's an explanation of what a function is in programming. You can think of a helper function as a variant that specializes in one task and can be used by different parts of a program that wants to perform that same task. Now that I finished with the click mechanics for the sliders, it was time to implement dragging. I realized that I needed to distinguish between dragging and clicking, so I split the click event into its constituents, mouse down and mouse up. The other reason for this split was because dragging itself consisted of two actions, holding and releasing. You can guess which of the two events they fall into. I decided that the click response would only fire when the user presses the left mouse button on the gradient. As for dragging, it would only occur when the user holds the left mouse button on the hue component slider. The logic for the click response was still the same. The only difference now is that it's in the mouse down event instead of the click event. It would actually work in the mouse up event as well, but I wanted all the detection to occur in the mouse down event. The dragging mechanics was a little more complicated. It required two more events, mouse move and mouse leave. The latter was for detecting if the user's cursor is outside of the color picker. When this happens, we can expect the user to lose control of the slider. Okay, so now I'm going to explain how the dragging mechanics work step by step. It all starts in the mouse down event. When the user presses the left mouse button, this event will check if the click occurred on the hue component's gradient, the alpha channel's gradient, or the hue component slider. If the third condition is met, then that means the user clicked on the slider. This causes the hue component slider to be tracked.
Have you seen this man?
For the programmers watching this video, what I mean is that a reference of the slider's HTML element is saved temporarily in a class property. The property holds the slider's HTML element, which is analogous to the user holding the slider. While the slider is being tracked, the user could either move the mouse while still pressing down on the left mouse button, or let go of the left mouse button entirely. If the first action occurs, the mouse move event is triggered. This causes the Y coordinate of the moving mouse to be passed to the helper function that changes the position of sliders, thereby making the slider being tracked seem like it's being held by the moving mouse. The second action triggers the mouse up event, which stops the tracking of the slider. This is done by emptying the property holding it. Since the slider won't be in the property anymore, the mouse move event doesn't fire. The last event, mouse leave, does the same thing as mouse up. The only difference is that the user doesn't have to let go of the slider for it to be released. It happens automatically when they leave the color picker. After I finished implementing the dragging mechanics for the hue component slider, I replicated it for the alpha channel slider. At this point, I was pretty much finished with the interaction mechanics for the hue component and the alpha channel, so now it was time to make the chroma component interactive as well. The first thing I did was create a draggable element for it, which I called the cursor. Unlike the sliders, it can move in both the X and Y direction. I made it see-through so that the user knows what chroma they're selecting, and also I made it automatically resize with the color picker. As you can see, it starts in the top right corner. I put it there on purpose because that chroma is closest to the starting hue, which is red. I had to create a new helper for moving the cursor. it has conditions to prevent it from going beyond the 4 edges of the chroma component. The cursor is centered on the mouse, so to prevent it from leaving the component, its center x coordinate cannot be less than the x coordinate of the left edge, or greater than the x coordinate of the right edge. Also, its center y coordinate cannot be less than the y coordinate of the top edge, or greater than the y coordinate of the bottom edge. I use this helper to implement the clicking and dragging mechanics for the cursor. As I was testing the movement mechanics, I realized that if the user wanted to select the colors on the edges, it would be better to allow the cursor to move slightly beyond the borders. So I went back and made some adjustments to the helper's conditions. Now the cursor was able to move around the edges, but it still couldn't fully escape, which is what I wanted. This change didn't work well with the see-through background, so I decided to replace it later with a background that matches the chroma the mouse is hovering over. In other words, the chroma below the center of the cursor. There was another problem. Every time the color picker was resized, the cursor didn't stay in the same position. To solve this, I made a class property to keep track of the cursor's current x and y coordinates as a percentage of the chroma component's width and height respectively. For example, if the width of the chroma component was 200 pixels and the cursor's x coordinate was at 100, then it would be located 50% horizontally. Having the coordinates in percentage meant that I didn't have to worry about the amount of pixels in the chroma component. The percentages are converted back to pixels after the color picker is resized, and then the resulting x and y values are used to move the cursor back to its original spot. Remember the canvas I made for the hue component a while back?
No.
Well, I finally decided to go back to it to implement the logic for getting the color data of the selected hue. Okay, so the first thing I did was add code to keep track of the y coordinate of the vertical sliders. It's similar to the code that tracks the cursor's position. Then I made some changes to the helper that resizes the hue component's canvas. It now redraws the gradient when the canvas is resized and returns the new dimensions. These dimensions are passed to one of the canvas's API methods called getImageData. Remember, the image or graphic in this case is the hue gradient. The method wants to know which pixels of the gradient to read, so it asks for an area on the gradient. The area is given as a rectangle. This is where the dimensions come in. Since I wanted to get the data of all the hue pixels on the gradient, I gave the method the area of the entire canvas. In return, it gives me the RGBA values of every pixel on the canvas. In case you didn't know, that acronym stands for red, green, blue, and alpha. The RGB portion determines both the hue and the chroma. Each of the 4 components can have a value between 0 and 255. That's because individually, they are made up of 8 bits. Bits are the digits of the binary numeral system. I won't be explaining it since it's not relevant to the color picker. All you need to know is that, in JavaScript, a pixel's color data has 4 parts. The method returns a 2-dimensional array made up of these 4-part pixel data. What I needed to do now was implement a way to use the vertical slider's y-coordinate to locate the correct 4 components of a pixel in the array. I created a helper for this. It uses both x and y coordinates to locate the pixel data. For the hue component, and also for the alpha channel later, only the y coordinate was necessary because the colors in the gradient changed vertically and not horizontally. This is the formula for locating the correct pixel data. To move pixel by pixel horizontally, the x coordinate must be multiplied by 4 since each pixel consists of 4 parts. To move down to the next row of pixels, the y coordinate must be multiplied by the number of pixels in each row. The number of pixels in each row is the same as the width. Multiply this by 4 because again, each pixel consists of 4 parts. Combining the 2 equations will give the array position of the R component of a pixel, which can be used for indexing the array. To get the other components, the position can be incremented. At the moment, only the RGB values change. They will be used to update the chroma and the alpha channel gradient so that they match the selected hue. The last thing I did was move the code for redrawing the canvas's gradient into its own helper. This decoupling was actually meant for the other two components because I figured their gradients will be changing a lot. By separating the logic, the canvases won't be dependent on resizing to be redrawn. I only did this for the hue component because I wanted them all to follow the same design pattern. The hue component was pretty much done at this point, so I moved on to the alpha channel. First, I created a helper for redrawing its canvas. Then I made a class property to keep track of the state of its canvas's pixel data. Just like with the hue component, the alpha channel's dimensions will be passed to its canvas's getImageData method in order to read the color data of its pixels. Afterwards, I created a helper for updating the alpha channel's gradient and used it to reinitialize the gradient. Finally, I made the alpha channel reflect changes in the hue by implementing the helper inside of the mouse down and mouse move event handlers. To make the chroma component reflect the hue, I replicated what I did with the alpha channel. I created the helper that updates the UI gradient and the one for redrawing the canvas gradient. Then I made the class property that keeps track of the state of the canvas's pixel data. And lastly, I implemented two helpers inside the mouse down and mouse move events. Now the chroma component shows the shades, tints, and tones of the selected hue. I noticed that I was calling a lot of helpers to update gradients and canvases to reflect the hue, and honestly, I didn't want to do that. So I made a wrapper function that does all of it for me. I even included extra helpers for updating the search bar's background, as well as the cursors, to reflect the hue. I was nearly finished with mechanics for the chroma component. I just needed to make the alpha channel and the search bar reflect changes in the chroma. Fortunately, I already had all the code I needed. I just had to put them in the mouse down and mouse move events. However, I ran into an issue. If I change the chroma and then change the hue afterwards, the selected chroma is forgotten. To fix this, I actually had to remove the helpers that update the background colors of the components from the wrapper function. You see, the problem was caused by the order in which they were called. It wasn't enough to just swap them around in the function because some of the helpers needed the RGB values of the selected color property to change. This could only be done outside the wrapper function, in the clicking and dragging logic of the hue component. After rewriting both of them to call the update helpers in the correct order, the issue was resolved. As a side note, this bug teaches a valuable lesson, not to abstract too much. At this point, I was pretty much finished with all the canvas mechanics, so I decided to work on the last component, the search bar. I wanted the user to be able to switch between different color formats, so I changed the UI for the search bar. It now has arrow buttons to cycle between the different formats. Naturally, I had to rewrite all the code that was linked to the search bar, so that they accounted for its new HTML structure.
One eternity later.
This is the reason why I tried to have a complete GUI at the start. Making changes to it can mean redoing parts of the codebase, which can be time-consuming and difficult, especially if the codebase itself is poorly designed. Okay, so next I made a helper for updating the text displayed in the search bar. Lastly, I made the arrow buttons able to resize with the color picker. After changing the search bar's UI, I realized I forgot to implement the mechanics for changing the opacity. So I went back to the clicking and dragging code for the alpha channel's vertical slider and added in the logic for updating the alpha value of the selected color. I did the same for the helper that updates the search bar's background, since it's supposed to display the selected color. As I was testing this, I noticed that when the hue is changed, the change in opacity becomes inaccurate. I suspected it had something to do with the alpha channel's canvas, but I tried to debug it and still couldn't figure out why it was happening. So I looked for another way of getting the opacity, and that's when the best idea struck me. You see, in CSS, one way to change the opacity of a color is to provide a decimal number between 0 and 1 to the RGBA function, which is the format my color picker uses under the hood. A decimal can be converted to a fraction and vice versa. The latter is what's important. It meant that I can get the opacity by converting a fraction of the alpha channel's height into decimal form. Basically, I had to find how far down the vertical slider is relative to the alpha channel's height and use the resulting fraction to get the opacity. I created a helper that uses this logic to get the alpha value, and I implemented it in the clicking and dragging mechanics for the alpha channel and the chroma component. Now the opacity is accurately reflected by the search bar. Finally, I deleted the alpha channel's canvas and all the code for it since they were no longer used. In the mouse down and mouse move events, I made multiple calls to the helper that updates the color code displayed by the search bar. I did this in the clicking and dragging mechanics of the three components. That way, every change in the desired color is reflected by the search bar's input text. While playing around with this, I realized that dark colors made the text and the arrow buttons difficult to see. To fix this, I needed to make them turn white in dark colors and black in brighter colors. Guess what I did next? I made another helper.
Oh, brother, this guy stinks!
It uses the opacity and the cursor's position to determine when to do the conversion. How it works is, when the opacity is greater than 50% and the cursor is inside this area in the chroma component, the text and the arrow buttons will be white, otherwise they will be black. I only implemented the helper in the clicking and dragging mechanics of the alpha channel in the chroma component. This is because only the changes in these components affected the color contrast in the search bar. Before I moved on to the last two mechanics, I actually did some housekeeping, or should I say code keeping. Basically, I reorganized parts of the codebase and tweaked some of the helpers so that they require less data to be passed to them. However, I didn't change their underlying logic, I only made them easier to use. Also, I forgot to mention that I made a class property to keep track of the color format being used by the search bar. Once I finished cleaning my code, I added more color format options to the helper that updates the search bar's text. Then I started creating the helpers that convert RGB to each of the formats. I did the one for hex first since that was the easiest. I didn't have to look up a formula because JavaScript already provided a way to get a number's corresponding hex value. For single numbers, I wrote code to put zeros in front of them in the output. After that, I did the one for HSL and HSV. I won't explain the formulas for converting RGB to HSL and HSV because frankly, I don't know the math behind them either. I found their formulas on this Wikipedia article. Feel free to visit it if you're curious. When I tested the RGB to HSL conversion, I discovered two closely linked problems. The first one involved the hue gradient. I realized that the last hue should have been red because the hue part of HSL was an angle that does a full revolution. This meant that it was supposed to cycle back to red, which is at 0 degrees. The second problem involved my conversion formula. I forgot to multiply the hue by 60.
Hey, y'all, come look at this.
To fix the problem, I used the HSL function in CSS to accurately recreate the hue gradient. After making these changes, the search bar was now displaying the correct HSL color code. When I created the RGB to HSV helper, I noticed the value part went from 0 to 100 and represented brightness. This gave me a bright idea. I went back to the helper that adjusts the contrast between the search bar's background and its text and arrow buttons, and I changed the logic so that it now uses the brightness value of the HSV format. This improved the accuracy of the change between white and black. The search mechanic was the color picker's last functionality. I started by adding a new event to the color picker, which basically detects typing. Then I wrote a bunch of code inside its handler that converts color code input into RGBA values that the class can store inside its selected color property. I passed the RGBA data to the helper that converts RGB to HSV. The reason I did this is so that I could use the HSV values to move the sliders and the cursor to reflect the color that was being searched. Getting the position of the hue slider was straightforward. Since the hue gradient is supposed to represent a full revolution, the H value can be divided by 360 to get a fraction of the hue component's height. The decimal form of this fraction is then rounded to the nearest whole number to get the y coordinate of the slider. This works because the fraction represents the position of the slider relative to the height of the hue component. Getting the position of the alpha channel slider followed a similar approach. Since the alpha value was already in decimal form, it just had to be multiplied with the alpha channel's height to get the y coordinate. Also, it had to be subtracted from 1 to make the slider start from the top. Remember, the top of the gradient represents 100% opacity and the bottom represents 0%. So for example, to display 60% opacity, the slider has to move 40% down from the top. Lastly, to get the position of the cursor, the S and V values must be converted to decimal form and be multiplied with the width and height of the chroma component respectively to get the X and Y coordinates. This works because the top right corner of the chroma component is where both the S and V values are at 100%, and the bottom left is where they are both at 0%. This implies the relative positioning can be used, kind of like what I did to reposition the cursor at its original spot whenever the color picker is resized. The fraction of the V value must be subtracted from 1 for the same reason as the alpha channel slider. I used the Y coordinate of the hue slider to get the color data of the hue, and use that to update the chroma component's gradient in Canvas. I made a copy of the RGBA values of the color that was searched, and used that to update the backgrounds of the other components to reflect the color displayed by the search bar. Now the color picker was complete. All that was left to do was add an API method to retrieve the selected color, which I did. Before I end this video, I just wanted to say thank you to those who watched the entire thing, and also to those who stuck around for a bit. I know some parts were technical and boring, but I wanted to show people who are maybe new to programming some tricks they can apply in their own projects. I plan to make more videos like this in the future. In fact, I actually started this channel to show off my projects, so if you want to see more, be sure to subscribe. You can download this project on my GitHub if you want to have a look at the codebase. It's also available in NPM as a package if you want to use it in your own projects. I don't mind if you use it for commercial purposes, but I would appreciate it if you shared my YouTube channel. That's all I wanted to say. See you next time.